So from the left, we've got our AC output 1, which is our essential output. So that's going to be powered when there's no ESCOM or AC input source connected. So that will be powered from your battery. Then we've got our AC output 2. That's directly connected onto the AC input. So as soon as the AC input becomes unavailable, the AC output 2 disconnects. So that can be used for non-essential loads or high loads that you want to disconnect from the system when there's a power failure. That's the same as connecting it before the inverter directly onto ESCOM. The AC out 2 output can also be programmed to stay on while during load shedding, according to or depending on battery state of charge or whichever state you set. And then we've got our AC input. So this is a MultiPlus II, so we've only got one AC input available. Then we've got our VE bus connection and our remote on-off plug. So the remote on-off plug is also important to make sure that that is back into the inverter.
Yes. What's currently the max load in the AC out? AC out 2,
AC out 2, so that's going to be depending on the contactor rating. So if you have a look at the part number or on the unit itself, so it's going to be a 48 3000 35-32 for this instance, or -50 for 5 kVA or -100 for the bigger units. So that's the maximum AC transfer capacity of the built-in contactor. So you can theoretically run the maximum capacity of that contactor. So with this on the 3 kVA, it's 32 amps.
Why is it smaller than the older units? The older units have a bigger contactor.
Yes, so on the MultiPlus II, 5 and 3 kVA has got a little bit smaller contactor built in. But yeah, that's because you're not going to be running 15 kVA on a 3 kVA unit inputs. Not that easily. So your AC output 1 can also theoretically transfer that capacity, but as soon as there's a power failure, you're going to be overloading the system if you're running too much power through the output. So make sure that on the AC output 1, you've only got the essential loads connected. So that's not going to overload the inverter system.
What is the capacity of the output 2 then? The one which is directly grid connected, is that?
Yeah, so when there's grid available, you've got your, for 3 kVA you've got 32 amps, for 5 kVA 50 amps, and for 8 up until 15 kVA 100 amps.
So 32 amps out on the 2 and 32 amps out on one of the batteries?
You're not going to be able to achieve that. So your AC input, one input is going to be limited to 32 amps.
Yes.
So if your loads is going to be drawing 16 amps, you're only going to have 16 amps available before you reach your limit. So then you're going to only be able to supply 16 amps. So, but if you've got...
So you can't feed 32 amps off the batteries and the 32 amps off of your AC input onto output 2.
You can, yes. So you can, not 32 amps, but so the maximum capacity of the inverter, I'm not sure what's the amplitude that's going to be. That's going to be about very close to 32 amps anyway. No? AC out. So it's going to be 12 amps on this one. So you're going to have a maximum 12 amp inverting capability. So that's still going to be limited to your inverter size.
Yeah.
What you can feed from the batteries. So you can feed 3 kVA from your batteries and 32 amps from ESCOM or from your generator to your loads. So it can assist in that way. And then next we've got our DC input connection on the right hand side of the unit. Over here we've also got our switch. So over there we can see we've got 2 positions. So that's one which is on, where the whole unit is switched on. So the inverter and the charger is powered. On switch position 2, only the charger is powered. So then the inverter will only charge your batteries, it won't supply any loads. So make sure that your inverter is also switched onto the correct position. So firstly, we're going to connect our battery onto our battery terminals now. Make sure we've got our wires either color coded. Just check the size here. So we've got our wires color coded or marked clearly which one is which one, so that we don't reverse polarity the units or connect our battery or inverter the wrong way around. So you can just loosen it up over here, and then you can shove it in through there at the bottom for me. Let's see if that one will fit. Going to really fit. So hold on, let's just grab the other cable there. That one's got a smaller lug. So grab this one from here and that one. Keep that one separate. So we're just connecting our negative wire onto the black terminals on the battery. And then that one can go to our inverter. You can unscrew that for us over there. So on our inverter, we'll connect the negative over here onto from our battery directly. So the torque ratings on the connections for the inverters are also indicated on the manual. So do take note that you don't over tighten the connections. But for demonstration, I'm just tightening it loosely. I'm not going to be drawing a lot of power.
So recommended torque rating?
Not 100% sure. I think it is 5 Newton meters. But that's for an M8 bolt. Yeah, just when it goes like and then you turn it back half a turn. So if we have a look here also, we can quickly go to our manual and have a look. Where is our manual? Getting there. So each inverter is also supplied with a manual. Or every product from Victron gets supplied with a manual. But if you do throw it away, you can go online and retrieve the manual again in PDF format or Excel. So we can go here, you can see in our index, let's see installation. Let's have a look here. 11. Let's check here, we'll mention battery connections. Battery cables. So there's our cable sizing guide. I always recommend to put 2 cables.
12.
There we go. So use a torque wrench with an insulated box spanner in order to avoid shorting, and then 12 Newton meters for the M8 nut. Most of the MultiPlus and Quattro inverters have got, or all of them has got the M8 nut on it. So you can torque that up to 12 Newton meters. So we can get that one off there, we can put that off there.
Was that bottom plate ground open, or is that how it comes now? Where the cable goes through? It's open. It comes like that now, it's ground open.
I think it comes like that, some of them. But they have got the...
I don't think I've ever actually seen that.
No, normally it comes with that.
It's got the plugs in there, just.
Yeah, but it's closed. It's not that one is open.
No, it is open.
Yeah, I'm not too sure, but yeah, this feels.
So remember, you've got a cover that comes over there afterwards.
This feels machined, though, yeah. So I'm sure they come like that now. Yes.
Just to avoid accidental shortage of the case, whatever, should be connecting the battery to the inverter first.
Say again.
You should be connecting the battery to the inverter first.
I always struggle
To
with
avoid accidental short.
tables in the.
Yeah, definitely to avoid any shorts. But because we've got our fuse installed, our fuse is still open, technically, and our battery is also switched off. That's a nice thing about the BMS controlled batteries. Not all of them are powered off when the BMS is off. So do take note, measure on the terminals to see.
Connect the cable to the inverter first.
What's the correct procedure if it's like not a smart battery or a BMS powered?
To connect.
Yeah, like what is it? I think it's red last, correct?
Yeah, so red will generally be connected last. So according to recommendations, that varies on standards, local regulations. But for recommendations from Victron, only fuse the positive wire. The communication bus operates on the negative wire. So if that link is going to be broken, you're going to struggle to restart the system in certain scenarios. So the recommendation is to fuse the positive wire from Victron only. Yeah. And then the negative is used for the communication bus as well. So from Victron's side, they do not recommend fusing the negative as well. That really depends on regulation. Some people vary.
I spoke to
all that.
electrical engineer, and I had it as positive only, and he said, according to South African, you have to have fuse both.
Yeah, so that's on the DC side, but the DC side is for PV, so it varies a lot. But yeah, so we're not talking about regulations or anything, recommendations.
But
from our
what does
side.
it make any difference in terms of communication? And
You're going to struggle, so if your fuse is going to be, or if you've got a blown fuse
yeah,
on one of the negative lines, the system isn't going to be able to recover.
so
So if you've got your ESCOM connected or whatever, but the fuse is blown,
but
then
I'm
the one
talking on
inverter isn't
DC
gonna be
now
able
from
to
battery.
recover.
Talking a fuse between the DC.
Yes, on the DC from the battery, yes.
So you mustn't have it on the negative on the DC battery.
You must install it according to regulations. We install it. It's going to be the best. You can't say yes or no. Yeah. So, yeah, but for demonstration purposes, we're connecting it directly over here. This box doesn't have the links distributed. It's got a crow's nest there at the back, or a dove's nest. So, yeah, theoretically, you would just tighten that first. On the batteries, they've also got the recommended torque settings. That's going to be indicated on the battery manual. That's good for now. There you go. We can just take that one there. Now this one has got a wrong lug. Just quickly, there's a bigger lug there. Just quickly turn it off for me there. Make sure you also use the right size lugs on your DC cables.
Is that a 5?
A 6. So if you have a 6mm lug and you've got an 8mm connection, you can't drill the lug to make it bigger, because the lug is sized to be 25 by 6. It's not a 25 by 8, so the carrying capacity is going to be reduced. Yeah, it's going to be bigger. It's going to be like this. So if you've got a 6mm nut, make sure you put on a 6mm lug as well. It's important. That whole, yeah, these studs, yeah. And then on the washer and spring washer you get, it's recommended always to put the washer, or you put your lug onto the connection, then your washer, and then your spring washer. So make sure that that's also the right way around, and then we can put our nut back. So we don't want anything between the connection and the lug as well. So that's going to cause hot connections. And you just torque it over there, torque it over here. All that's good. So you make sure our inverter is switched off, and then the procedure would usually be to start up your battery. As soon as the battery is started up, do your measurements, double check, and then triple check. Then you close your fuses, and then you double check and triple check, and then you can switch your inverter on. Check if that's got power over there.
It's not going to switch. So the BYD won't turn on if it doesn't have comms with the battery management unit. So it can pick up if there's no comms.
So then it switches off.
No, it will stay like that. It will only give out 5 volts.
Okay.
So you can test your polarity if you really wanted to, but the unit won't turn on.
So you do require this box.
Yeah.
So you do require then this box to be plugged in before your BYD is going to be switched on. So for that to communicate, I'll just use the supplied cable, and that plugs in on the BMS port.
Yes.
BMS port, and then on the battery out. Battery in. So on the battery in, but that will all be indicated on the BYD manual as well.
It might still not switch on until you connect the BMS type A.
BMS type A as well. And then for communication, we've got our specific cable, which is indicated by BYD. This is our BMS type A cable. Battery BMS CAN type A. So to see whichever batteries are compatible and which communication cables they use, and we can go onto Google and we can just search Victron Compatibility. And then we'll see the first result. It's going to be our battery compatibility. And then over here, it will throw out all of the supported compatible batteries. So here you can then see, click on the BYD. It is on the B boxes, are they? Under that, the B boxes. So you can just go onto BYD or whichever battery, and then it will have the correct procedure for Victron and that compatible battery for the setup.
Connect your genes on there as well.
The startup procedure for BYD and Victron is different to what's suggested right now. Never start the battery first. All fuses closed, all communication done. Then only start the battery because it has a pre-charge resistance built in. So you can damage those circuits if you start up and commission the battery correctly.
So you just close the whole circuit, and then the battery, and then the inverter.
Because otherwise it's going to stay at 5 volts. And what happens at 5 volts? Nothing. Because the Cerbo and all those units only start from 9 to 7 volts. So nothing will start. Where if you follow the procedure with recharge,
Let's first connect the servo.
recharge the circuit. So the Cerbo and that will come
It also
on.
needs power.
Then you can start the battery clean. Maybe we should restart it. If there's anyone who would like to copy the presentation, the sequence, you can just plug up the sponsor and set it up online. Or it doesn't work here. Doesn't work yesterday.
Yeah, I'm just winging it. I'm not following the manual. Well, okay, so we first also need to power up our GX device. So we'll just quickly connect these wires for us over here. So we'll make sure our battery is switched off. That's powered off. So we can just loosen that up there for us. And then we can put the red wire on this side. Just put it on behind the washer, the spring washer so fast. Yeah, just don't touch all 3 wires at once. Yeah, okay, so on the battery compatibility, if we go on the manual, we can see on the CAN bus wiring between the battery and the GX device. It indicates that it uses a VCAN Type A cable. So this is also a pre-made up cable. It's available from Victron. Comes in 1.8, 3 and 5 meter lengths, or 3 and 5 meter lengths only, I think now. So 3 and 5 meters, pre-made up. But you can also just Google the Victron CAN pinout and it will show you the pinout for the Type A and Type B cable if you want to make your own.
Just an interesting question. Last year when I went on some Victron training, they told me that self-made Type B and Type A cables can lead to warranty loss instead of using a Victron Type A and Type B.
Yeah, certain batteries manufacturers will indicate that you certain requirements. Like for instance, some batteries require a GX device also if you want warranty. So you read the fine print on the batteries. So on the BMS CAN cable, we've got 2 sides. So one is marked Victron VE CAN. So that can go into your VE CAN if that's set up correctly, or into our BMS CAN because we've got a dedicated BMS CAN port. So we'll chuck that one in on our BMS CAN. That's located furthest to the left on our Cerbo GX if it's mounted upright. And in the other side, the battery BMS CAN Type A will plug into our, what do you call this box?
BMU.
BMU. So on the BMU, it just goes into the inverter port. Yeah, they don't know this before, sure. It's got lost. Alright, so now our communication wiring is set up. Battery is connected. We still don't have a termination on our GX device. You'll get that now.
So is this white box acting as a BMS?
It is the BMS.
Okay.
BYD.
Okay.
The BMS will connect or LPS or whatever performance battery to be able to communicate to the proprietary software from Victron something.
Right, now I've got a Blue Nova, so mine's built in.
So now we've got the termination plug. So this goes onto our VE CAN. So here on our GX device, we've plugged in our BMS communication cable. So the other open port, the one right next to that one, we'll plug in the termination plug.
Must
you
you
see
plug that
right
in?
behind there,
Yeah.
you must plug it in, yeah. So for VCAN, it's a requirement to have the terminations on the beginning of the communication line and the end of the communication
So why
line.
haven't you got it in the BMU?
A BMU's got built-in termination.
Yeah.
So
It's on the newer models, not anymore. They do recommend still putting it in. It's just to keep dust and things out, but it's not really needed anymore.
So between the batteries, they run on a different protocol. I don't think they run on CAN, so that's RS485. So the link between the batteries don't require a termination plug. It's just a CAN bus. So that's from the BMU to your GX device. It requires one termination. The other termination plug is built in. Same as with the Solar MD, they've got the termination plug built in, so you can switch the terminator on. Or if you deactivate the built-in terminator, then you have to physically plug a terminator plug in on the Solar MD. But yeah, so certain BMSs has a built-in termination plug, so it won't be a requirement to put the termination plug in. Okay, so we've got all that connected. Got power in there, so holding our power. Wait for the click. See if we get a lights over here. This battery could also be quite flat. It's been standing for a time, but that's the nice thing about lithium is the self-discharge rate isn't that high.
Okay, then just quickly, for those of you that weren't here yesterday, BYD's firmware or commissioning of the battery is done via cell phone or laptop. So you can just go and download BYD Battery Box, App Store, iOS. Once you open it up, it will search for new firmware. Always download it, please. Don't skip this process. So all you say is okay, it'll download the new firmware. Turn your phone's Wi-Fi on, and all you say is go to Wi-Fi settings. It will pick up the Wi-Fi from this unit. You can just click on it, and then it will have a password on the side, which you can see right there.
BYD box is our standard possible.
Yes.
Yeah, so that's a standard. That's BYD-B box.
Yeah.
Just check for the
Standard.
capitalization. But it's on the side of the unit here. WAN password.
It's capital or case sensitive, so
Yeah.
it needs to be perfect.
So do note, once you are in, your phone will show that you don't have internet access because you're using this unit's Wi-Fi. Alright, so that's not weird. So if it asks you, do you want to keep it, or say always?
Yeah, always connect.
Yes. Then you can go back to the BYD, it'll open up, it will install that firmware onto the battery. It's usually a pretty quick process, as you can see. I'll just give it a moment.
Good to learn. These BYDs are very good batteries. But these are second life B boxes. They're first life.
Now BYD battery is second life. Older than the first life. It's not other than that is like.
What is second life mean? Refurbished?
Yeah, second use.
So it's
For the
cells
cell.
coming out of electric vehicles, electric buses from somewhere that continue for the life of that vehicle that has been installed in a battery.
Stationary installation.
It's quite important to read that fine print of the battery. Not all of them mention it outright because they why would buy that battery, although they can service quite a lifetime still. But first life cells are much better.
Yeah, for warranty purposes and life expectancy. Any questions so far?
Still saying that being open is new. I literally had to grind down those nipples to get the cables in.
I'm not sure, but I know
It's supposed to have the
That's the
rubbers.
only way to force it in was to actually grind a little Dremel tool, and I ground down the thread on to make it so that, because I'm using bigger cable, then you can't hook the lug onto those nipples. There's not enough
this is
space.
quite an old unit, 21. It could be.
Maybe it's
On
old.
the
and
3
then
kVAs,
don't look like that.
On the 3 kVAs, they had a lot of
Looks
change.
like that. Yeah.
And the 3 kVAs, they changed it quite a bit. It just came out.
I always struggle with that. So I've never seen that.
Yeah, because it has to connect at an angle like this, straight.
And it doesn't. Forget about it.
Alright guys, so once the firmware update is done, you'll get a little warning that just lets you know that the firmware could update and it could power cycle. So just to let you know, once that is done, it'll ask you for a configuration. So you have to do this because sometimes the battery won't physically give out power even if you didn't do this. Alright, so all you say is yes, it'll ask you for date and time. It'll ask you what unit is it running on. It's a Victron in this case. It'll ask you what type of battery it is, so you'll choose Flex Light. Quantity, we've only got one. It'll ask you if it's on-grid, off-grid or backup. This is only for bookkeeping info. It has no effect on how your system will perform, so you can choose either one. And then important is single phase or three phase. And all you say is next, and it'll give you a little rundown of everything that you have chosen, and you can just say next, and the configuration is then done. You will get a little info tab showing the cell voltage of each cell, temperature, SOC, and so on. Yeah, we should be.
Great, and now it should be
good now.
what is power.
Run number 1. It's now in the middle.
What is this button?
It takes 15 minutes.
Does it take a while?
You have to wait at least 15 minutes.
Okay, let's have a 15-minute break.
Yeah, so sorry guys, I just had to do a little firmware update. So once the firmware update is done, it might be inactive for 10 minutes. If it doesn't do anything, turn it off, turn it back on, and you should be all good. I did check, it did take the firmware. If you log in again, it will do a quick load, and if there's nothing major happening, all is fine. So yeah, so the battery is currently just powering the Cerbo, and yeah, do you have any questions regarding the commissioning process?
This battery has also just been in the truck for 6 months already, so it was in dire need of a firmware update to work. Cool.
Oh, and then sorry guys, on the app, you'll see at the top, it has a BMU section. If you have a system that has multiple batteries, the top part will be an average of all your batteries. SOC, maximum cell voltage, minimum cell voltage, temperature, min and max, and it will show you how many batteries you have. And then at the bottom, you'll see it says, in this case, BMS 1, because there's only one battery. If you have multiples, you can go into depth on each of them and see that battery's minimum and max cell voltage, temperature, how much current is being drawn from it, and voltage, and so on.
How many of those batteries can you have in this?
So for the Flex, you can do a maximum of 64 batteries to 320 kilowatt odd hours. We've got LVSs that can also do 64. You're then limited to about 4 times 64 kilowatt. And on the bigger one, the LVL, which is a 15.4 kilowatt, you can do again 64 of them, and that's almost 1 megawatt hour if you wanted to.
That's a big system, so. Okay. So next up, we're going to start with just a firmware update on the inverter. I'm going to grab my MK3 over here. So for programming the Victron inverters, you require the Victron MK3 interface to USB. So that's just supplied by any Victron distributor. As an installer, you're going to require one for each installation team, and that is required to update the firmware or settings on a Victron inverter. So that's the MultiPlus or Quattro range of inverters. So to change any settings or update any firmware on that, we're going to require the MK3 to USB device. So for programming, we're also going to just use a normal straight RJ45 network cable. So that's going to be plugged into my first or last inverter. For this setup, it's just a single phase setup. So I'm going to plug it into my inverter on the V bus port, and then take my wire and plug it into my MK3. It's got an RJ45 port there. And then the other side, I can just go to my computer. So that's has to be a Windows computer. The software we can get, let me just grab a chair here. Seat here. So for the software, we can go to victronenergy.com or .co.za. And then over here on the top right, we've got downloads. So if we open up our downloads, we'll see we've got Victron Connect for Windows and all that. Go a little bit further down, we've got the VE configuration tools for VE bus products. So we'll download that tool, and then once that's done downloading, we'll just install that. So that's just a basic installation of the Victron tools. So once that is installed, we'll see, let me just open up here. We go into our apps, we go down to Victron, V. You'll see we've got our VE configure tools, and then in that folder we've got the VE bus quick configure, the VE bus system configurator, VE config, and then VE flash. And then we've got a help file over here, and then the uninstallation tool. So to update the firmware on the Victron Multiplus or Quattro inverters, we're going to be using the VE flash software. So once that's opened, dragging it over there. So then we open up the VE flash. It's going to greet us with the welcome screen. It's going to say that this program is used to update the firmware of your Victron device. Some devices can be upgraded. We're not going to do that. So press start to continue. So select the required action. It's always going to be the default, which is update the firmware. So we click on next. Now it's giving us a warning stating that updating will reset any user-defined settings to default. So if you've got a running system that you want to go and perform an update to, and you want to retain those settings, you're going to have to close the firmware update, open VE config, go and save the settings file, and then re-open the VE flash and continue. But if you've got the manual at hand and you know what the settings are, it's standard settings, not something special, then you can just update the firmware and reconfigure the system yourself. But do note that if you update the firmware, the system does get reset to defaults, all settings. So now we can click next. Now it's asking us to select our file. So now, in order for us to identify which file we need, we can go back to Google and we just go to our professional portal. So that is professional.victronenergy. Also, if you go onto Victron's website, at the top right, it's got the login for VRM or professional portals. You can just click on that. It will take you to the professional portal. So that's the website you use to register for this training. So on the left hand side, we'll then see there's an option for firmware. You can go there. We can connect it to Dropbox if you've got Dropbox. First time you're going to open this up, it's going to require you just to accept the disclaimer. So just click OK. And then over here we can see all of our products' firmware files which is available, but we're only interested in the V-bus multi-inverters and quattros. That's the only firmware file we're ever going to come and fetch here. Maybe a Venus software, if you want to downgrade any Venus device, you can come and download it over here, but generally you always only get or come here for the V-bus firmware. So if we open up this folder over here, we'll see inside that folder there's a text file which is named V-bus firmware numbers, or text. So we can open up that document. And then here we've got all of the Victron inverters, V-bus inverters over here. So now we can go and have a look at the side of our unit, and we can check our part number, and we can just type in or search through the list for our MultiPlus II 48/3000 /35-32. So that's the part number on the side of the unit. So now I can see here I've got a few options. So I've got one with an external sensor. So that's not on the part code of this unit. And over here I've got another one with an external sensor. So it's also not that one. It's not indicated on the part number. My part number is just the MultiPlus II 48/3000. So that's only on the 48/3000 units, where you've got a few different units. But for that one, all of the latest ones are going to be the 2629 hardware ID. So that's the hardware identification number of that specific unit. So that's the MultiPlus II 48/3000, the same unit that is used in the EasySolars. So now we've got our hardware number, so that is 2629 for our specific installation. Now we can navigate back to the professional portal. We can go back to our V-bus folder, and we can see we've got a folder over here which starts with 26, so we've got 26. So we open up that one, that's the first number on our hardware ID. And we can see we've got a few different options over here. So we've got non-assistant firmwares, we're not interested in that one. Assistant firmwares, but it's deprecated, so it's no longer supported. And then we've got this assistant firmwares 400 file. So we open up that one. We can see there is some older firmwares available if it's needed, but generally for 99% of the installations you're going to use the latest firmware. So now we can scroll down here, we can navigate to the corresponding number. You can tell me what was that number?
2629.
So that's a 2629. So we make sure you've got that one. So we download that one. Let's just navigate that one also. And then let's navigate back to our VE Flash.
Quick question. Is this the same firmware update that I normally do on BMS?
Yes, so it will be the same firmware, yeah. But it's when you're doing the commissioning, it's recommended to always do the setup with the latest firmware when you're doing the setup. So update the inverter, update the MPPTs and all the devices, and then commission the system.
Yeah, the reason why I ask is it wrong the way that I do it. I don't put the input on, I just configure my battery, then I put the inverter on, then I configure the touch to all its right settings, enable two-way communication, go online on VRM while I'm on site, and then load the firmware, and then start my setup.
You can do it that way, but yeah, that's if you don't have an MK3, you're going to have to do it that way. But it's easier, quicker just to do it with an MK3. Plug it into the unit itself,
Yeah.
and do all the settings, yeah. but it's exactly the same function as doing the gateway. So on commissioning, now it's asking us just to select our file. So we've downloaded that file, so now we can just browse to our downloads folder. So our downloads folder, and we select that one. So let's say, yeah, so we've downloaded the incorrect one for a reason. So let's say by accident you're dyslexic or your technician clicked the wrong one. So you downloaded the wrong file, but you in any way just carry on. Click next. So now it's going to tell us to prepare our system. So remove all connected accessories like the GX. So when updating multi-compacts, so that's the older units, they discontinued by now. The MultiPlus II, so if you ever come across one of those, it's required to disconnect the AC input. It's only on the MultiPlus compact units, so no other units is required. So in case of a multi or parallel phase installation, the devices have to be updated one by one. So switch all units off except the one to program. So now I just require somebody to switch that unit on for me. Will you quickly switch it on for me? Thanks. Just make sure that it's on position 1. Alright, so now we've got it followed over there, and click next. So now it's asking us to select a COM port. Because our device is switched on, we can go and click auto detect. It's easiest just always power the device on and auto detect it, then to go and have a look at what COM port it's on. Now it's asking us connect part 1. It's telling us to switch off the device, disconnect the mains if we've got a compact, and connect the communication cable. So we can just switch it off again back to position 0. And we've got our comms connected. And we can click next. Now it's just asking us to switch on the device again. And then once it's switched on, you'll see that there's no lights coming on the inverter, so that's fine. We want that. Means it's in program mode. So now it's going to say connection established. Press next to start programming. So we click next, and now it's going to tell us, oh no, ID error occurred. File not suitable for this device. So it's going to say we tried to upload a 2628, but the device requires 2629. So now we say, okay, go back, and we reopen our VFlash. We make sure we go and download the correct firmware. So we've got the 2629 downloaded. And we've got our VFlash opened again. Now we can just go through that again. We want to update the firmware. You know that it's going to reset it to defaults. We make sure we select the correct file. Open it up. Click next. All our accessories are disconnected and all our devices are switched off, so we can just switch that one off and back on again for us, and then back on. So because it failed for during the update, it's still in program mode, so we must just power cycle it. Now we can click next and auto detect our COM port. We can click next. It's going to ask us to switch it off.
So if you
just stand by there.
If you're updating via VRM, then those instructions
Switch
don't
on.
apply.
No.
Because you can't disconnect devices, then the Cerbo doesn't try.
Yeah, but then it requires a Cerbo for the update. So a Cerbo is actually fine, but like on the color control, you've got problems. So it's just, we recommend just disconnect it while you update it from yourself laptop. Disconnect everything and you won't have problems. So now the device has been switched on. We can click next. Now it says connection has been established. Click next to start programming. And now we'll see it will successfully install the firmware to the unit. Any questions?
I'm assuming you guys have tested this on the macOS platform with the
M1 chip as well? Because I've discovered that in some, especially with ESL batteries, I can't use my
Parallels.
my Mac OS to update any firmware. I have to buy a laptop just for that.
Yeah. So the problem with the Mac M1 Max and upwards is they run on a different type of Windows. So it's the ARM64. So that's not going to work on these x64 based software. So yeah, with the M1 Max, you're going to struggle to get around most of the Victron software to run that. Windows software to run that. But it will be sorted within a few years.
A few years.
Yeah, a few years. Yeah, they're working on that. It's a new platform, so it takes a while. So now Inverter has finished updating the firmware. So can we now go home? No, we can't, because the inverter is going to overcharge our batteries. So let's first now open up our next software for single phase inverters or one inverter. So that's going to be the VE config. Okay, so now with our VE config open and our inverter is switched on, we then go up here on top, we've got port selection. The first option is COM port. We go there, get it up. Delicate. You can auto detect again, that's going to be the best. As you can see here, we've got a few different COM ports. So auto detect, and it will automatically connect to the COM port which has got the MK3. I was going to read the current configuration on the device. And open up the config file. So now over here, we're greeted by the general tab. First option we've got over here is our system frequency. So that's standard at 50 Hz. It's always going to be at 50 Hz for South Africa. Next one, we've got our shore limit. That's our AC input current limit. So that's, if you've got a Quattro, you'll have two options available to configure over here. But because we've got a MultiPlus unit, we've only got one AC input available, and that is configured at its maximum availability. So if we open it up, we can see our default value, our minimum value, and the step size value, 30.1 amps. That's a new one there. And then the current configured value. So if you want to change this value over here on the inverter itself, you can. And then right next to that, we've got the option for overruled by remote. So that's if you've got a GX device plugged in, you can change the AC input current limit from the GX device. But if this is deactivated, you'll only be able to see what is the input current limit, but you won't be able to adjust it. Next over here we've got dynamic current limiter. That's related to limited supply or smaller generators. If we right click on this over here, we can see that it's got an option over here for what is this and info. So I can click here and say what is this, and then it will pop up a help file telling me exactly what is the dynamic current limiter. So over here specifically, they've got it set for a small generator like a 2 kVA. So what that does is instead of running 32 amps from your generator, which can only supply 6, it's going to ramp up 1 amp, 2 amps, 3 amps up until 6 amps, and it's going to try 7 and 8, and it's going to see, oh no, but the supply can't keep up. I'm only going to draw 6 amps because it looks like my supply can only steadily supply 6 amps to me. So that's what the dynamic current limiter does. Limited generators can activate that. External current sensor, if you've got a unit with an external current sensor. So any settings, you want to see what it does, you can just right click on it and it will tell you exactly what that setting does. Next over here we've got our battery monitor. So that's the built-in battery monitor of the inverter. That gives the inverter the capability to work out more or less where is the battery state of charge at the given moment. So if you don't have a GX device connected, then the inverter is never going to know or have an updated value of the battery state of charge. So then it's required to set this exactly according to the battery manufacturer specs so that you can have an accurate indication of state of charge. Not perfect. So over here, first thing it's going to ask us is to modify our battery capacity. So that's the size of our battery. So over here we've got a 100 amp hour battery. So that's the amp hour rating. We have to input over there. Next we've got state of charge when bulk finished. So this is the state of charge at which the inverter is going to switch over to absorption state. So for lithium batteries, they require to be charged at the constant voltage, constant current up until 95%. So for any lithium battery, that value is 95%. But for lead acid batteries, it varies. It's from 70 to 80%, depending on the type of battery. Charge efficiency, the next option. So no battery can ever be 100% efficient. So for lead acid batteries, that used to be quite a bit lower, 70% maximum efficiency. But because of the new technology on lithium, we can have efficiencies of up to 99% claimed from the battery charge to discharge cycle. So for majority of the lithiums, the charge efficiency is going to be 97%. So this value works in an increment of from 1 being 100 and 0.01 being 1. So just make sure that you put it in as 0.97. But if you input the wrong value, it's not going to be able to give you value without boundaries. So I make sure I type in 0.97 over there. That's good. The next option we've got here is our grid. So this unit has already been configured previously on South African grid code. But out of the box, the unit is going to come on none. So feeding energy to the grid is not allowed at all. You can't run ESS on none as well, so it is required to select the grid code. So if you are installing in Cape Town a MultiPlus II inverter, then you must select the South African grid code. So we've selected the South African grid code, and then next option we've got here is the AC input related settings. So here we've got LOM detection or loss of mains detection. What that is it measures how quickly the voltage drops or the frequency drops, or if it rises above the input value. So or input parameters on the units. So with LOM detection switched on, the unit is going to disconnect quicker from the power source if it sees that the voltage looks like it's starting to drop or the frequency is starting to drop. Then it's going to disconnect quicker to try and protect your loads from any low voltages or unnecessary frequencies. But if you've got a generator connected on the input, then it's going to be disconnecting from the generator the whole time, if it's a limited generator as well. Because now, once you start loading the generator, the voltage and frequency drops a little bit, and then the inverter sees it as a failure, and then it's going to disconnect from the generator. And reconnect, going to initiate the charge, and then disconnect immediately. So that's where the LOM detection then has to be disabled for generator. But do note, if you disable the LOM detection, then it's not going to be compliant if you've got grid on that input. So then you're not going to be able to get sign-off for the system. So let's say you have changed it, or it's a requirement to change it, it's also going to ask you to enter the grid code password. So over here we can say yes, and then that password is not available on the internet or from your distributor, but that is a TPW MBU 2A4GCC. So that's standard grid code password has been for the last 6 years. It will always be that password.
Is this information in the book?
No. So on the internet maybe not, but so it's generally not a requirement to change any of this. But if you've got a generator or you selected the wrong grid code and you want to change it back to South Africa, then you are going to require the access password. So that's only to change the grid settings on the Victron inverter, that password. So now that our LOM detection has been disabled, we cannot legally connect to an ESCOM source on that input. So it's recommended to install a Quattro where you've got a generator on the system, so that you've got this dedicated input for the generator, and you can have dedicated settings for that input. So we can disable the LOM detection for our generator input, which is never going to be connecting to the grid, so it is compliant. But our grid connected input has got LOM detection, so it is still compliant as well. Over here, right below that, we've got our IPNS logs, so that's protection logs. So if you've got a running system that has connected to the grid, it's disconnected or whatever, over here if you open this up, it will show you all the most recent disconnect reasons from the grid. So if it's a drop in voltage or drop in frequency, or a rise in voltage or rise in frequency, it will indicate it over here. But for that you physically have to log in on the VE configure to access that. Here on the side we've got our NRS grid code settings. So over here we can have a look at what is the parameters at which it's going to connect and disconnect. And the only thing we can adjust is the reconnect time. But that's standard on 60 seconds, only if it's disconnected. Not sure, let's have a look. Amen. This one. Going there. Jy gaan direk na hom. Ja. Goeie. Goeie, hier is hier gekry, maar dat is ag. Right. Wat awesome. Okay. Let's right click on this, say info. Doesn't have any info on that for me. Not sure what that setting does, but it's going to be related to the NRS requirements, obviously what South Africa wants. Next we've got our inverter tab. So here we can adapt our inverter output voltage. So when the inverter is operating disconnected from the grid, it's going to output this voltage. So over here our minimum is 210 and our maximum 240. So some instances I've seen where the grid voltage is maybe 215 most of the time, and then when there's a change or power failure or the power recovery from Eskom, then the lights dim or brighten, and that's due to the voltage difference from Eskom and the inverter out. So if that's close to like 220 from Eskom, then I would adapt my output voltage to be 220 to match that closer.
Sorry, is that change in voltage also potentially what causes some digital clocks to run fast?
I'm not sure about that, but I think it's more frequency on the digital clocks.
Frequency is not voltage.
Yeah.
All SOA systems where the frequency shift, they would have the clocks run fast or slow. But SMA had a second thing that would automatically, during the nighttime hours, drop the frequency or item it again to correct it. Yeah, I haven't seen it on Victron.
Yeah, so the voltage shot mostly doesn't affect that stuff. Next, we've got a ground relay. It's completely grayed out because we've got our South African grid code selected. So our ground relay has to be activated. So that's just bonding the neutral to earth when the inverter is running on inverter mode. Next, we've got our DC input low shutdown. So for this, I'll navigate back to Google, and I'll go back to our battery compatibility. And we go there. We go to our BYD, whichever battery we're currently installing. We read all those things. We jump to the V configure settings. So here's the Victron VE configure settings page. So over here, let's have a look what they're indicating for us over here. Here's one inverter setting. That's where we are currently. So if I go move this to the side, I can have a look and see that our DC input low shutdown, that's the value at which the inverter is going to disconnect from the battery to save the battery or no longer discharge the battery. Specifically, a must-have for or must configure correctly for lithium batteries. Otherwise, your BMS trips before your inverter disconnects, and then you're going to struggle to recover that BMS. Some BMSs are more forgiving, but most of them you're going to have to get a battery out on site or a charger or some other source to recover the battery. So make sure that's set according to what the manufacturer recommends, maybe even slightly higher. So you can see that BYD recommends 47. So you want to be maybe safe, you can say 47.1, and you've got a little bit extra leeway as well. Then we've got the DC input low restart. So that's recommended at 51. So after it's disconnected at 47 volts, the battery voltage must first climb by 4 volts before it's going to start inverting again. So if you don't have a DC charger, your battery is never going to recover and the inverter is never going to switch on. Over here, next option is our DC input low pre-alarm. So on the inverter, we've got a low battery alarm LED. So this is the value at which that LED is going to start flashing. So over here on the manual, we can see that they've got a note on that, set to 51. So here they say the pre-alarm setting is dependent on your preference and on site-specific requirements. You may wish for this to be activated earlier or later. So let's have a look here what they recommended over here, BYD. So if the system is configured in ESS, you may not wish to have this alarm trigger until below the sustained voltage, e.g. 49 volts. Okay, so let's put that at 49 volts, because we're going to run an ESS Assistant. Then here on the side, we've got shutdown on SOC, but that's going to be as accurate as the settings over here. And the battery capacity. So some batteries will have 101 amp hours, and in that drift over a long period of time, you're going to end up having your battery at 100%, but the Victron is going to think it is at 95% or whichever. So it's not too reliable, unless if you've got a GX device, then you can activate that, because the GX device synchronizes the battery BMS SoC with the inverter. Then we've got the do not restart after short circuit. So that's deactivated by default. So what that does is if it measures a very low impedance short or overload on the output, the inverter won't automatically recover. So you're going to have to go out the side, switch it off, switch it on again. But it's not going to work if you pick up a short on a long cable and the short is at the end of the cable, and it's going to continue feeding that short, because the wire resistance is going to add to that accuracy. Then we've got advanced energy saving. So what this does is if the inverter wattage is below a certain threshold, the inverter goes into a low power state where it only sends a 1 Hertz pulse once every second, and as soon as that pulse gets loaded, it's going to see that there is load again and switch the inverter on. But on power supplies and all that stuff, it doesn't work at all. So if you've got an element light or a heater or something, then it works reliably. But yeah, any LED lights or something with a power supply, you're going to have to start up 500 watts before it registers that there's a load. But generally, we don't use that. It's maybe for automotive. We want to leave the inverter on. It's in a non-accessible place. We can activate that. The next tab is our charger. So here on top, we can activate or deactivate our built-in charger of the inverter. Then we've got weak AC input. So South Africa does have weak AC, so I always activate that. And what that does is it gives a little bit more slack on the input parameters from the system. So if you've got a system which is in the bundus, in the middle of nowhere, on a very bad line, and the voltage fluctuates, in the morning it's at 250, but at night or when in the middle of the day it's at 200 volts, then your inverter isn't going to want to charge your batteries on that voltage fluctuations. So then it's required to enable the weak AC input. Otherwise it's only going to bypass the power, never charge your batteries from your mains. Stop after excessive bulk, that's required for lead acid batteries. The lithium batteries is where we're getting to now. So now we can go back to our manual and we can just consult our charger tab. So here they've got some parameters over here, so let's input those. So our battery type, go on top right, you can open that up and we can see that we've got lithium iron phosphate. So we select that. It's going to give us an overview of everything that is changed. We say OK. Now we can see it has ticked lithium batteries for us. Configured for V-Bus BMS is deactivated because we don't have the V-Bus BMSs here in South Africa available. This is for diagnostic purposes only. You want to disable the voltage sense. Never ever has that been a requirement. So the charge curve is fixed. So that's a recommendation from the battery manufacturer. On absorption voltage, so we can see that BYD recommends for ESS system 55.2 volt, and absorption for an off-grid system is slightly higher. But we've got a grid connected system, so we can just set that to 55.2. We've got our float voltage, so also indicate, so that we can make 55. And our maximum absorption time is 1 hour, so that's also a recommendation for lithium. Here at the bottom we've got our charging current, so we can open that up. We can see our default value, so it's always set at the maximum, so that's DC charging amps. So if it's a 48 volt unit, it's going to be 48 volt or 55 volt, whatever your charging voltage is, at 35 amps. Or for the bigger units, whatever their charging amp rating is. So if you open it up, you'll be able to see what is the default value, which is going to be the maximum, the minimum value, and then the step sizes are a bit bonked. For now, they're 1 amp, so you can increment it by 1 amp steps. So if you've got multiple inverters, do take note that you don't overcharge your battery, because if you're going to have 3 inverters, that charging current is going to be multiplied by 3. So if our battery can only handle 100 amps, I'm going to have to adapt that, divide 100 by 3, and then input that. It's going to be 33. But we've got 1 unit, 35 amp is our maximum, so we are good with that. So now let's say we're going to install 1,000 BYDs this year, and I don't want to go and have a look at the manual every single time to get the voltages. Now I can go to my battery type, and then on the left I can say create new type. So this is only stored on your computer or your technician's computer, or whichever one you save it on. So now it's saying you're about to define a new battery type, so with all these values. So we say yes, and then we call that a BYD, what is this thing again? LV Flex. LV Flex. Here we go. So now let's say next time we get to site, we configure all our other settings, we get to charger, we can go battery type, and we can select our BYD Freedom 1, Solar Angry, or whichever we've added onto our computer. Now all that is configured, we go next, which is our virtual switch. So for this we're going to say do not use virtual switch. But let's say we haven't changed it, and we want to go to our assistance. We're going to see that it says the assistant functionality has been disabled because a virtual switch is used. To enable the assistant, select do not use. So I can tell it to show me where, or tell it to do this for me. So they'll just activate it for me. But that is just located over here. Now we can have our ESS assistant added. So now we go to add assistants, all assistants, and ESS. Now we'll see that it's selected. If we've got multiple assistants added, we must make sure that we select our ESS assistant and start the assistant. Now we're going to be greeted with the welcome remarks on the energy storage system assistant. It's going to give us a link to the ESS manual. So if we open that one up, you can see over here, it takes us to a close page. We can just open that. So here we've got 3 ESS manuals. So we've got a quick installation guide, design and installation manual, and all that. So here it's got a bunch of different types of ESS systems, installation equipment, how to set it up and all that. Going to give us a list of requirements and all that. We click next. Now it's asking us for settings regarding our battery again. So we go back to our battery manual. We'll double check. Here we've got ESS system settings. So here we see battery system. So here they indicate that we must select the one which is the LIF FEPO4 with other type BMS. So this can be a BMS connected via CAN bus or a BMS system in which the batteries are protected by external equipment. So 100% of the time if you install a lithium battery, you're going to select this battery type. So we click on that, click next, battery capacity, we already changed, that is correct. Now it's asking us, do we want to change our battery type to adapt for lithium, but we already adapted it and all our parameters according to BYD, which is our specific battery we are installing. So we don't want to change the manufacturer's recommended parameters. So we say do not change battery type. We click next. Now we can see the sustained voltage. So when the batteries are left in a deep discharge state for prolonged times, so if your PV hasn't been producing for 2 weeks, or if you've got a backup system running ESS, you're going to wonder why does the system only charge the battery to 50 volts. It's because you're running ESS on a backup system. But if you've got a solar connected and it hasn't been producing for a week, it's going to see that the batteries are sitting at 30% for a week. Then it's going to just apply the sustained voltage to the battery bank and thereafter charge the battery up 5% every day until PV production is recovered or the battery is up to 100%. So sustained voltage for BYD is 50 volts. Now we've got our dynamic cutoff. So this was more related to lithium, lead acid batteries. So for the lithiums, they are generally easy to set, either all the same value or close to the same value. So for BYD, they recommend setting all these values to 47. So we've got that. So what this does is, at the given discharge rate, the inverter is going to ignore the disconnect parameters and can disconnect at that voltage. So for this battery, it doesn't matter at which rate it is discharged, it's going to reach close to 0%, maybe 5% SOC at 47 volts guaranteed. Whereas with lead acid batteries, if you discharge it at a low rate, you can have the battery at 0%, but it's at 48 volts still. But if you discharge it at a high rate, the battery can be at 90%, but it's sitting at 42 volts. So that rate will change there. But for lithium, it's very easy. Restart offsets. So regarding the previous settings, if it disconnects the inverter due to low voltage, how much must the voltage recover before it reconnects again? So recommended over here is 1.2 volts. PV inverters. So if there's any PV inverters connected on the AC output of the inverter system, this is where we would configure it. So for this instance, we're just going to say no. Click next, and it's going to give us an overview of the VE config settings that we have changed on the inverter. Click next. So now all the settings have been changed, but not uploaded to the inverter. So next step for us is to go here at the bottom. We've got the option for get settings. So if we accidentally click that, we're going to have to reconfigure everything again. So make sure we go and first say send settings. Send what? We want to send the modified settings or all the settings. So we just want to send the modified settings. It's okay. And we click OK. It's going to upload it. It's going to say, do we want to upload the assistant setup to the device? But the device will be switched off while the assistant is written. We say yes. So it powers off the inverter and writes the setup. It's going to say assistant setup successfully written, and the inverter will start up again. So now, let's say we want to save our settings for future reference. So we're here on our assistance tab. We have to save our assistant separately. So here we can say this is the Kranich BYD assistant. I can save that one. And then same up top over here for the settings of the inverter. I must go up my file and I can say save the settings, and then I can name it for whichever name I'm going to remember for future reference. I know the VSC. Take off that shortcut. So also, if you want to have a look at the settings later on without having to open up the computer, you can also say export the settings, and then here from on you can print it and have all those settings printed for you in human readable form. And then you can save it. If you like to save it, and say yes, and it's going to save it as a text file. So you can then say settings. There you go. Then you can now send that file to your technician, and you can have it on his cell phone and see the settings and set it accordingly. Also here we've got the V-Bus monitor. If we open that up, it's just going to give us a little bit of a bigger overview of what is going on. So we don't have any grid connected, so it's not in phase. Our DC voltage, DC ripple. Let's show DC ripple here. Yeah, here's our DC ripple. Our DC current, inverting or charging. And we can just say close our simple monitor. Yes. And then you've got a digital multi-controller. You can set the input current. Yeah. Cool. Any questions?
I just want to verify something. Input current, it's Cape Town specific now, I'm not sure. It's supposed to be 15 amps or any amount of amps that your inverter can handle, but someone told me it must be set low, so it takes longer to charge, otherwise it's going to have an issue.
It's just now recently they do require inverters to not charge once there's a power return or recovery. But yeah, so it's still going to take a while to be implemented.
Okay.
25% of your circuit.
Thank you.
Yeah, I'm not too sure about that. Yeah, I think let's have a short break and everything, and then I think the on-phase guys are going to be here after that. That's the grid tie systems. Great, thanks.
So you're done.